Hello my dear students, good morning to all of you. Today we will discuss on these two topics, okay. First one is conduction and breakdown in pure liquids, and another one is conduction and breakdown phenomena in commercial liquids, okay. As we already started with the first model, basically we are going to study about the conduction as well as the breakdown phenomena in the presence of the gaseous dielectric medium, liquid dielectric medium, and one more is solid dielectric medium. Is it right? So in the previous class we have already studied about the conduction phenomena as well as the breakdown phenomena in the presence of the gaseous dielectric medium, right? So now basically these liquid dielectric mediums, so the basically liquids are of two types is there. One is a pure liquid and one more is the commercial liquids, okay. So in these liquids, how the electrical phenomena like a conduction as well as the breakdown process takes place, we'll study today, okay. First one is conduction and breakdown in pure liquids, okay. Okay, see here. So basically what is the main difference between pure liquids and commercial liquids we need to understand, okay. Pure liquids means what? Pure means, as its name only it indicates that these are chemically pure itself. Chemically pure in the sense that it does not consist of any other impurities. Impurities means what? So the impurities, due to the presence of impurities only, the dielectric strength or the breakdown strength of the oil it is going to be reduces. So which are those impurities will be usually present in the liquid dielectric means? So like dust particles or any moisture content or any dissolved gases like oxygen, carbon dioxide, or any other ionic impurities like water vapor. So these are the common impurities will be present in the pure will be present in the liquid dielectrics, not in the pure, okay. Pure liquids means these are the chemically pure and it does not consist of any impurities, and these are structurally very simple in nature, okay. So, okay, when it comes to the commercial liquid means those commercial liquids which are not chemically pure, and it usually consists of the impurities like gas bubbles or any dissolved gases will also be present. So due to the presence of those impurities only, the dielectric strength or the breakdown strength of the oil it is going to be reduces, okay. So now first we will study about these electrical phenomena like a conduction as well as the breakdown in which liquids? Pure liquids, okay. So examples for these pure liquids are, one is the N-hexane, and this structural formula, atomic formula is this one, C6H14, carbon atoms will be 6 and hydrogen will be 14, okay. And N-heptane, C7H16, paraffin hydrocarbons. These are the examples for the pure liquid dielectrics, okay. So now, so this is the characteristic curve between applied electrical field to the two electrode system. As we already familiar with the two electrode system. Two electrode system means one it is the cathode and the anode is there. Between these two electrodes there is a small distance. This distance or the gap, it is completely filled with the liquid dielectric medium, okay. So when we apply the voltage based on the application of a lower voltage or the higher voltage, which phenomena we have studied? Conduction as well as the breakdown process. Is it right? So like that only, let us consider the curve. So this is the curve. First thing is that, so first you observe here how the conduction of current versus the electrical field characteristics in presence of which liquid dielectric? That is hexane. Hexane is C6H14. Getting my point? So basically, suppose when we apply a low electrical fields to the two electrode system. So that is low electrical field in the sense that if it is of a 1 kilovolt per centimeter, if you had applied means the conductivities of a liquid will obtain from the range of a 10 raised to minus 18 to minus 20 itself. So whenever we apply the low electrical field, that is of how much? 1 kilovolt per centimeter, okay. So these conductivities probably these conductivity what it is obtained, so that may be less because of the reason that the probably it may be due to the presence of impurities even after the purification process. Is it right? In the previous class we have already studied about the how the purification of the liquid dielectrics as well as the breakdown test also we have discussed. Is it right? So first, when we apply the low electrical fields, that is of a 1 kilovolt per centimeter, then the conductivities which are obtained in the order of a 10 raised to minus 18 to minus 20. But so these conductivities probably it is very less because of the reason that due to the presence of the impurities. Getting my point? So however, next thing it is, when we apply a higher volts, what will happen? High fields, if you had applied, that is in the range of if it is greater than 100 kilovolt per centimeter, then what will happen? So initially when we apply a higher voltage, the current not only increases rapidly, is it right? Immediately after the application of the high voltage, the current it is not going to be increases very sharply, rapidly it is not going to increases, is it right? So currents not only increases rapidly, it will take some time here after this, but next thing here, but it will go the some fluctuations, this due to the because of the high voltage application between the two electrodes in the presence of the liquid dielectric medium. So what will happen? Initially the current does not increases rapidly, but it undergoes fluctuations. Getting my point? After some time, these fluctuations also get die down. So completely get dying down in the sense that the breakdown of the dielectric medium. Getting my point? So that is why, so this curve, it is modified and redrawn like this. So how we have redrawn? Just we can see here. So first thing here, this curve, this curve means what it is that on the x-axis what we have taken, applied electrical field in terms of what, megavolt per centimeter, and this is on the y-axis what we have taken, the amount of conduction current itself, the conduction current. So the unit will be ampere only, is it right? So this on y-axis we had taken. So this curve only we had modified and we have redrawn like this. Okay. So this curve, it has a 3 distinct reasons are there. So which are those 3 reasons? Okay, let us study now. Okay. The first reason here, first if you apply the very low fields or nothing but the low voltage, if you had applied the 2 electrode system, then what will happen? So at a very low fields, the current occurs is due to the process called as a dissociation of ions. So what is this dissociation of ions means what? So dissociation is nothing but the splitting up of the molecule. Which molecule? That is liquid molecule. Getting my point? The splitting up of or the separate ionic compounds separated into the smaller ions or split into the smaller particles like atoms or ions itself. Getting my point? So at a very low fields, due to the dissociation of ions, the current it is going to be occurs. Getting? So this reason it is going to be called it as a ionic reason. Next comes to here in middle reason. So it with the intermediate fields, the current, the whatever the conduction of current will be there, so that is going to be reaches its saturation level here. In the middle region, the current reaches its saturation level when the applied field is of a intermediate. So next comes to another third reason here, whenever the applied field is high. Getting my point? At a higher fields, the current is going to be generated. The amount of conduction current or current is going to be generated because of the process called as a field aided process. What is this field aided process? So field aided electron emission from the cathode. Keep it in mind. On the cathode, how the electrons are going to be gets emitted? So as we already studied, is it right? So secondary electrons are going to be, due to the secondary ionization process, the electrons are going to be gets emitted from the cathode. How those electrons are emitted? So due to the impact of the positive ions or due to the impact of the photons or due to the impact of a metastable or the neutral atoms. Is it right? On the cathode, suppose for example, let us consider if a UV ultraviolet radiation of a suitable frequency, if it is going to be incident on the cathode, means what will happen? Some amount of electrons are going to be gets emitted from the cathode itself. So field aided process means it is nothing but the electron emission from the cathode. Nothing but what? Electrons are going to be multiplied. So huge number of electrons gets emitting from the cathode. It is nothing but what? Current it is going to be generated. So what is the definition of a current? Current, it is nothing but the flow of electrons. Is it right? If the electrons are going to be gets multiplied in nature, means obviously the huge current it is going to be gets build up, right? So what that current it is going to be generated because of the process called as a field aided electron emission from the cathode itself. So these electrons are going to be gets multiplied in the liquid. So by the process called it as a Townsend's breakdown mechanism. Getting my point? So these are the three reasons. Keep it in mind. This is very important. Okay. So this curve means the relationship between what? Electrical field as well as the conduction current. So this curve is divided into how many reasons? Three reasons. Which are those three reasons? The first, it is at the lower fields, and the second it is at the intermediate fields, and the third is at the higher fields. Okay. So the first reason, it is going to be call it as a ionic reason. It is mainly because of the reason that the current it is going to be developed mainly because of the dissociation of ions. And the second thing is that the amount of the current reaches its saturation level when at intermediate fields itself. And here on the third reason is nothing but at the higher fields. Higher fields, the amount of the current it is going to be gets multiplied, or it is going to be increases rapidly. So because of which process? That is field aided electron emission from the cathode itself. Getting my point? So these are the three distinct reasons. So next comes to I told about this one, right? The current multiplication, that is also going to be occurs because of the reason that electrons generated at the interface of liquids as well as the impurities. Getting my point? So very important thing is that whenever the current at a higher fields, the current it is going to be generated, it reaches its saturation level. Nothing but if current is increases beyond the limit, means that leads to what? The liquid dielectric media which is present between the two electrodes gets breakdown. Getting my point? So that is why the breakdown voltage, it will be depends upon the very important factors. Which are those? The first one is the applied field. So what applied field means? So there are three reasons I told, right? Initially we are going to be applying the low fields, after this intermediate fields, after this high fields. So getting my point? So the breakdown voltage depends upon the applied electrical field to the two electrode system. So next comes to gap separation. Gap separation means the distance between the two electrodes. So next comes to the cathode work function. Cathode, it is the work function is nothing but the function at which the amount of the electrons liberated from the cathode due to the impact of the ultraviolet radiation on it itself. So next thing here, very important thing is that breakdown voltage, it also depends upon the physical properties of the liquid medium. So what are those physical properties of the liquid medium? Basically the viscosity of the liquid, or the liquid temperature, or else density of the liquid. One more is what is the molecule structure of that liquid. So these are the factors which will decide or which will determine the breakdown voltage. Getting my point? So this is all about what? The conduction as well as the breakdown process in the presence of which liquids? Pure liquids. Getting? I hope this is clear to all of you. Okay. So next comes to, next we'll move on to another one is conduction and breakdown process in the which liquids? Commercial liquids. Getting my point? So the commercial liquids means what? The commercial liquids means, as I already discussed, commercial liquids are not chemically pure. So not chemically pure in the sense that what is the meaning of this one? It is nothing but the commercial liquids will be consist of impurities like what? Gas bubbles, any suspended particles. So we can observe it from this figure here. So the liquid dielectrics or the commercial liquids will be consist of these are the gas bubbles or the water vapors which are present in the oil itself, and these are the suspended particles like either it is any dust particles or any fibrous material. So due to the presence, in this oil only the fibrous material is present. This is one kind of impurity. Solid decomposition products will be present in the liquid dielectrics. Okay, so these are the impurities which usually present in the liquids. So getting my point, due to the presence of these impurities, it will reduces the breakdown strength of liquids. Okay, so then what we have to do for this one, when breakdown, suppose when a breakdown occurs, so let us consider, suppose when a breakdown occurs in these liquids, then what will happen? Breakdown occurs in these liquids means additional gases and some gas bubbles are going to be formed. So suppose in these commercial liquids the breakdown process it has taken place means some additional gases like dissolved gases like oxygen, carbon dioxide, some additional gases as well as the gas bubbles are going to be formed. So that results into what? That results into a formation of a solid products in the liquids. So due to the presence of the solid decomposition products, the breakdown strength of the oil it is going to be reduces. That is why the breakdown mechanism it mainly depends upon these three factors. The first one, what it is there? The nature as well as the condition of the electrodes. What is the meaning of this one? Nature in the sense that, so either it is a sphere electrode or it may be uniform parallel plane electrodes. Getting my point? So condition in the sense that either it is a smooth surface there or there should not be any irregularities on the surface of the electrodes. That is very important. Surface of the electrode should be free from the dust particles. It should be very smooth in nature. It should not consist of any irregularities on the surface of the electrodes. That is also determines the breakdown mechanism. Keep it in mind. The first factor is nature and condition of the electrodes. Second thing is physical properties of a liquid. What are the physical properties of the liquid I told? So the first one is viscosity, whether it may be viscosity of the liquid or density of the liquid or the molecule structure of the liquids, or it may be we can say what temperature of the liquid. So these are the various physical properties which determines the or predicts the breakdown mechanism. So next comes to here impurities and gases which are present in the liquid. So these are the three important factors which determines the breakdown mechanism. Okay, next thing here, so this breakdown mechanism which occurs in the commercial liquids, that is explained. So this breakdown mechanism it is going to be classified as follows. Which are those classification? Means the first one is suspended particle mechanism, and the second one is cavitation and bubble mechanism, and the third is thermal mechanism, and the fourth one is stressed oil volume theory. So these are the four mechanisms, classification of breakdown mechanism in commercial liquids. Okay, let us study one by one right now. So the first one is suspended particle mechanism. What is the meaning of this one? Suspended particles means what? Suspended particle mechanism. Suspended particles will be like what? Any fibrous material. So is it right? So in this oil we can observe, so this is the fibrous material or any dust particles are going to be collected and settled down at one side of the oil itself. So this results into what? Due to the presence of these fibrous material or any dust particles, what will happen? The breakdown strength of the oil it is going to be reduces. Is it right? So that is why the impurities will be present as a fibrous or a dispersed solid particles. Getting my point? So now let us, what we will consider now, the like what first one is, so let us consider first basically, for example one oil will take, for example transformer oil will consider. Okay, the transformer oil it is a liquid dielectric, right? So the permittivity of this transformer oil or a liquid dielectric, I consider it as a epsilon 1 itself. Don't get confused. The permittivity of the transformer oil or any liquid dielectric you consider. The permittivity of that liquid I consider it as a epsilon 1. So next thing here, so the presence of these fibrous material particles, that permittivity of that particle will consider it as a epsilon 2. Obviously, right, the permittivity of this particle, nothing but impurities particle, will be different from the permittivity of the liquid itself. Epsilon 2 is the permittivity of the impurity particle and epsilon 1 is the permittivity of a liquid. Example, what I had considered? Any oil you take, transformer oil, petroleum oil or a silicone oil, any oil you take. Okay. So now, if you consider the impurities particle, nothing but permittivity of these particles is epsilon 2 I had taken. Is it right? So, if we consider the impurities of in a spherical form, let us next what we are going to assume it. So, the impurities which are present in the liquid dielectric which are in the form of a spherical form. If they are in a spherical form means we will take into consideration of their radius. Okay. The spherical particle which is of a radius r, keep it in mind. So, next after this, the particle when we apply the electrical field means the particle experiences a force, electrostatic force. So, this force will be given by equation like this. F is equal to 1 divided by 2r cube into the bracket of epsilon 2 minus epsilon 1 divided by 2 epsilon 1 plus epsilon 2 gradient of E square. So, where r is the radius of a spherical particle means impurity particle, and epsilon 2 is the permittivity of the impurity particle and epsilon 1 is the permittivity of the liquid. Getting my point? So, next thing here. And whatever the force it is going to be developed, so this force is usually directed towards the areas of a maximum stress itself. Suppose the oil is there, so this is the fibrous material. So, this material what will happen, so due to the density of this density will be more here. So, this fibrous material or any dust particles get settled at the one area itself. Getting my point? So, this force is usually directed towards the areas of a maximum stress. Getting my point? So, next thing here, suppose if you keep on applying the voltage continuously to this kind of a system means what will happen? If the voltage is continuously applied DC or the duration of the voltage if it is long means AC we can apply. So, then what will happen? These forces what they will do, they will draw the impurity particles towards the area of a maximum stress. Getting my point? So, these forces when we apply the continuously, if you applied the DC voltage to this two electrode system, so then what will happen means these forces will drive all the impurities particles at the areas of a maximum stress itself. Getting my point? So, next what will happen? If the number of particles, which particles? Impurity particles. Okay. If the number of impurity particles are in large in number, then what will happen? So, if the number of particles, impurity particles are large in number means these particles are going to be aligned themselves. Due to what reason? Due to this force itself, due to the electrostatic force what it has been developed. Okay. Due to this force, the impurity particles are going to be aligned and form a chain like a structure. Keep it in mind. So, those going to be form a chain like a structure. So, these impurities are a chain like a structure acts like a what? Bridging between the two electrodes. Is it right? So, in the two electrodes there will be a small distance, that distance will be covered with the liquid dielectric media. So, these impurities are going to be acts like what? They will form the chain like a structure because of this force and going to be acts like a bridge between the two electrodes. Getting my point? So, suppose when this bridging occurs between the electrode gap means that results into a, because impurities are increasing, they form a gap it is completely bridged with the what? Impurity particles. Impurities particles or the any suspended particles if it is increasing in the liquid dielectric medium means what will happen? The dielectric strength of the oil it is going to be reduces. Then we are keep on if you are providing the voltage supply means that results into what? Breakdown of that dielectric medium, right? So, that is why the dielectric or the breakdown between the electrodes takes place when the impurities forms the bridge between the electrode gap. Okay. So, now This is all about what it is, suspended particle mechanism. So next thing here, so suppose the larger the size of the particles, which particles? That is impurity particles. Suppose the size of the particles, if it is large, means the breakdown strength, it is obviously reduces, right? So breakdown strength of the oil, it is going to be reduces. So next comes to another one is cavitation and bubble mechanism. So first we need to understand what is cavitation. Okay, so cavitation, it is nothing but it is a mechanism, or it is a process in which vapor bubbles are going to be formed. How those vapor bubbles will form? Getting my point? So cavitation is a process or the mechanism in which rapid changes of pressure in a liquid that leads to the formation of what? Small vapor filled cavities. Getting my point? Or a small voids, or else we can say that the pressure is relatively, if it is low, or due to the difference of the pressure in the liquid, that leads to the formation of a vapor bubbles. Getting my point? So small vapor filled cavities are going to be formed due to the, because of reason of what? Due to the rapid changes in the pressure of a liquid medium. Getting my point? So next, apart from this pressure difference or a rapid changes in the pressure, vapor bubbles or the cavitations are going to be formed. So some other processes which are responsible for the formation of a vapor bubbles are, so these are the 4 processes how the vapor bubbles are formed in the liquid medium. Okay, so the first one is the gas pockets at the surface of the electrodes. So electrodes means one is the cathode is there, anode is there. On the surface of these 2 electrodes, if the gas pockets are going to be formed, gas pockets in the sense that it is the impurity. Gaseous, dissolved gases like oxygen, carbon dioxide, it is one kind of a impurity. If these gas pockets, if they are present at the surface of the electrodes, means that results into a formation of the vapor bubbles in the liquid. Okay. So second thing is due to electrostatic repulsive force between which charges? Space charges. So that also which may be, so this force may be sufficient to overcome the surface tension. Due to this electrostatic forces between the space charges, the vapor bubbles may form in the liquids. Okay. So third one is gaseous products. Gaseous products due to what reason? Dissociation. Dissociation means what I told? Or a separation or the splitting up of the molecule. Which molecule? Liquid molecules. Getting my point? So due to the splitting up of or a separation of the liquid molecules into atoms or ions, dissociation of these liquid molecules. So that is mainly due to the process called as a electron collision. Getting my point? As we already studied about the collision process, right? So due to this dissociation of a liquids by collision process, some gaseous products are going to be formed in the liquids. So that results into a formation of the vapor bubbles. So next, fourth one is vaporization of a liquid by corona type discharge. So what is this discharge? Corona type discharge means what? As we already discussed, is it right? So corona type discharge, it is nothing but the bluish glow. It is going to be occurs at the pointed ends of a metal conductors. Due to which reason? It is mainly because of the process called as a ionization. Keep it in mind. So due to corona type discharge means a bluish glow which going to be occurs at the pointed ends of a conductor or a metal conductor, due to because of which reason such kinds of a or nothing but the electrical charges are going to be leaking off through the air itself. Getting my point? Or we can say that due to the ionization process, a bluish glow it is going to be produced around the metal conductors. So that discharge it is going to be called it as a corona. So that is also due to the vaporization of such liquids during this kind of a corona type discharge also there is a chances of formation of the vapor bubbles. So these are the 4 mechanisms, these are the 4 processes which will be responsible for the formation of what? Vapor bubbles. Okay. So next thing here, suppose in the oil. Let us consider any oil itself, either it is a transformer oil or a petroleum oil. Okay, so in that oil, if a vapor bubbles are present, okay, so the bubble, the vapor bubble will elongate. So that is going to be gets elongate in the direction of the applied electrical field itself, under the influence of which forces? Electrostatic forces. What I told here, suppose if you consider any oil, means if the water vapor bubbles, nothing but the impurity, if it is present, means when we apply a electrical field, means these bubbles are going to be elongate in the direction of what? In the direction of the applied electrical field only, under the influence of which forces? Electrostatic forces which have been developed. Getting? So the breakdown process which occurs when breakdown occurs, this is very important. Okay, when the breakdown will occurs means when the voltage drop along the length of a bubble it is going to be gets elongated. Is it right? Length of the bubble it is, length of the bubble, when the voltage drop along the length of the bubble, if it equals to the minimum value on the Paschen's curve. Already we have studied about the Paschen's curve, right? The Paschen's curve, it will give the relationship between what? Gas pressure. It is mainly gives the breakdown voltage. It mainly depends upon the gas pressure as well as the ratio of applied electrical field to the pressure itself. Is it right? So on that curve we'll get some value. This voltage drop along the length of the bubble becomes, when it becomes equal to the minimum value on the Paschen's curve, means the breakdown process will takes place. Getting? So that breakdown field, it is represented by E naught. So that will be given by a equation. This is standard equation. You need to remember this one. 1 divided by epsilon 1 minus epsilon 2 into the bracket of 2 pi rho into the bracket of 2 epsilon 1 plus epsilon 2 divided by R. So flower bracket pi by 4 root of VB divided by 2R E naught minus 1 raised to 1 by 2 it is. Getting? Where rho is nothing but the surface tension of the liquid medium. Okay. Epsilon 1 is nothing but the whatever the liquid we are going to use here. Example, transformer oil. So the permittivity of that liquid is epsilon 1 and epsilon 2 is the permittivity of the impurity particle. Okay. So next thing here, where R is nothing but what? Radius of the spherical impurity particle. So next comes to VB. VB means what it is? VB is the voltage drop in the bubble and E naught is the breakdown field. Okay. So and very important thing is that this theory, what it has, this theory, it does not taken into account the production of the initial bubble, and hence the results given by this theory do not agree with the experimental results. So this cannot be able to meet the practical, theoretically as well as the experimental results are not going to match each other. Getting my point? So this is all about the cavitation and the bubble mechanism. And the third mechanism or the third theory, what it is there, one more is stressed oil volume theory. Okay, stressed oil volume theory means here the breakdowns in commercial liquids where minute traces of impurities will be present here. Is it right? So due to the presence of these impurities only, the breakdown strength it is going to be reduces. So that breakdown strength is determined by the largest possible impurity. If the impurities are in larger number, it is nothing but what? Or it is also going to be called it as a weak. Strength of the oil will be very weak, very less itself. Is it right? Or it is also going to be called it as a weak link in a commercial liquids. Getting my point? Suppose in a commercial liquids where a minute traces of impurities if they are present, means that breakdown strength of the oil, how it is going to be determined? By considering the largest possible impurity, or it is also going to be called it as a weak link. Okay. So now the breakdown strength of the oil, is defined by the reason. How will define? So first thing is to identify the where the impurity, for suppose if you consider the transformer oil, it is there. In that transformer oil, the suspended impurities like what? Fibrous material is there. So the fibrous material, it is going to be settled down at one side of the oil itself. Getting my point? So that reason, so the breakdown strength of the oil, it is mainly defined by the a reason where, which is stressed to the maximum extent. If it is stressed to the maximum extent means obviously it will be a weaker reason, right? So because impurities are more. So impurities, due to the presence of maximum impurities in the liquid dielectric media, the overall breakdown strength or a dielectric strength, it is going to be reduces. So that is why, suppose if the non-uniform fields, in case of a non-uniform fields means the stressed oil volume, the stressed oil, its volume will contains the maximum stress between the value of E max to 0.9 times of the E max. This E max, it is nothing but the applied electrical field, which is of a non-uniform in nature, means the volume of this, the stressed oil volume contains the stresses between these two values. Okay. So this theory, which theory? The stressed oil volume theory defines the breakdown strength, so which is inversely proportional to the stressed oil volume. So getting my point? In this theory, what they told, the breakdown strength of the oil is inversely proportional to the what? Volume of the stressed oil. Getting my point? So now the breakdown voltage, in this case, stressed oil theory, what it has explained means, basically they have taken into consideration of the physical properties of the liquid itself or the oil. So the breakdown voltage is determined by the how much amount of the gas content which is present in the oil itself. The gas content in the sense that either it is any dissolved gases like oxygen content or a carbon dioxide, any gases. Getting my point? So the based on the content of the gas content in the oil, the breakdown voltage is determined. So next one is physical properties of the oil like viscosity, pressure, temperature or the molecular structure. So these are the things. So next very important is impurities which are present in the oil will also determines the breakdown voltage it is. Getting? So that is why, so this curve what I had considered, so this curve is the nothing but the on the x-axis I had taken the stressed oil value in terms of a Cc, it is there, and here it is the breakdown voltage or the breakdown stress itself in terms of kilovolt per centimeter. Getting my point? So this for two different oils we have taken this curve. So this is the power frequency 50 Hertz where AC breakdown stress as a function of a stress oil volume itself. So this curve has drawn when we experimentally got this results. Okay. So, but we can conclude that from all the study above theories, whatever the theories we have studied, which theories we have studied till now. So, the first one is the what? The first one is which one? That is suspended particle mechanism, and the second one is cavitation and bubble mechanism, and the third is stressed oil volume theory. But these three theories which explain the breakdown phenomena in liquids, but it is not clear that no single theory can explain all the experimentally whatever the observation they have done, they are not unable to meet this one satisfactorily. They can't able to explain the breakdown mechanism in a liquid dielectrics. That is why the recently developed, for this purpose what they have done, the recently developed fast optical techniques have been used for studying the breakdown process in the liquid dielectrics. Getting my point? So that is also it is a recent developing the fast optical technique, it is going on. Okay. So this is all about what it is from exam point of view. This question is very important and it is fixed question, you may get it, you can accept it, this question in a external also. Okay. Concentrate on this one, the conduction as well as the commercial liquids. These three theories or these three mechanisms are very important. This question from exam point of view, just concentrate on this. Okay. I hope this is clear to all of you. We'll find up it now. Okay, next class we'll start with the one more is there. What is means Till now what we had studied, the conduction as well as the breakdown phenomena. In gaseous dielectric it is over, and in presence of liquid dielectrics it is also over. Then what is remaining? As well as one more we need to study about the solid dielectrics, is it right? In the presence of solid dielectrics, the various electrical phenomena is like a conduction process, and one more is the breakdown process. Okay, so in next class we will discuss on the conduction as well as the breakdown process in the solid dielectrics. Okay, so in solid dielectrics, so there are again there are so many types of mechanisms are there. So that also we will study in the next class. Okay, so if that bit, if it is going to be gets over, means that completes your first module. Okay, so as soon as possible we will wind up this first module. Next we will start with the module 2 regarding the high voltage generation, high voltage as well as the high current it is going to be generated. So those techniques we will study in the next class. Okay, thank you.